All right, we're going to take notes today on multi-step equations. And our essential question is, what should you try to do first before you treat it like a regular two-step equation? Hopefully I'll be able to address that here. If you think about it, we know how to use a two-step equation. We're just adding some more steps in, so we're just adding a little bit more. So if you look at your power notes right now, and I've written the steps out for you, so let's kind of go over them together. Okay, I told you first you need to distribute if it's necessary. That doesn't mean it always happens, does it? Okay, so that may be something you might have to do. Also, combining like terms, and I'm going to add here if necessary, because again, this may not always happen, but you might want to look for it. Oh, you have it written on your notes that way. If it's necessary, that's another thing that you want to check for. Then we want to do at that point is use inverse operations with the constant, which is the no variable, the one without the variable. And we're going to add or subtract. Then we're going to do inverse operations with the coefficient of the variable term, and then we're going to multiply or divide. Now this part here is what we've been doing already, right? This is like a regular two-step equation. Nothing new. Okay, so we've been doing that already, so we kind of are familiar with that a little bit. So we're just adding these new things. We're going to maybe distribute, maybe combine like terms, maybe add an extra operation. We're just going to kind of take a look at that and see where it takes us. Okay, so let's kind of get started. And let's take a look at example number 1. Okay, and example number 1 is this, so write it down. 2x plus 1 divided by 3 equals 7. Okay, 2x plus 1 divided by 3 equals 7. And we're going to draw a line, separate our sides. If we kind of look on the left side, you see that the divided by 3 is kind of far away from the 2x plus 1. So that's what we're going to get rid of first, because it's the furthest thing away. It's kind of like opening a present. You're going to start from the outside and work your way in. So what we're going to do is we're going to multiply both sides by 3. And this 3 we're going to put over 1 because it's a fraction. And we know anything in the numerator will cancel anything in the denominator and make it go away. So then we get 2x plus 1 equals, and 7 times 3 is 21. So this is looking a little bit better already, isn't it? Like a two-step equation. So now we're going to deal with the constant. And since this is plus 1, we're going to subtract 1 from both sides. And we get 2x equals, and that's 20. And we're going to try and get that x alone again, and we're going to use inverse operations with that coefficient. So since it's multiplying, we're going to divide both sides by 2. And we find out that x equals 10. And before we commit, remember we have to check. Checks get a little bit more involved as we go along. 2 times 10 plus 1 divided by 3 equals 7. And we're going to work it out. So we're going to use order of operations. 2 times 10 is 20. And 20 plus 1 is 21. So now we have 21 divided by 3 equals 7. And 21 divided by 3 does equal 7. So that works out. So our answer, x equals 10, it is a good answer. Okay? We're going to move along to the bottom of your page there where it says example number 2. So let's go there. Example number 2 here, and we have 7x minus 3x plus 4 equals 6. Well, the thing you know about collecting like terms is actually really cool, because if there's more than 2 things on a side, that means we need to collect like terms. Here we have 1, 2, 3 things on the same side. So since we have 3 things on the same side, we're going to put them together. This 7x minus 3x, they have the same variable to the same exponent. So 7x take away 3x is 4x. And then we're at this point now, 4x plus 4 equals 6. So then it's a two-step equation. We deal with the constant. So instead of adding 4, we subtract 4 from both sides. 4's go away. We end up with 4x equals, and 6 take away 4 is 2. This is looking funny, but don't worry about it. Things always work out. We're going to divide both sides by 4. And notice, guys, that 2 divided by 4. That 2 divided by 4, that 4 is a little bit bigger than that numerator, isn't it? Okay, so that means that when we simplify this, 2 divided by 4, this is really 1 over 2. Do not think that that is 2. Just because you see a 2 and a 4, oh, it must equal 2. And the numerator is smaller, so it needs to stay like this. So what we need to do is we need to check it to see if 1/2 really is the answer. So we're going to have to do some work with our fractions, but that's okay. 7 times 1/2 minus 3 times 1/2 plus 4 equals 6. Okay, now this isn't 7.5. We have to fix this. We have to put it over 1. And 7 times 1 is 7, and 1 times 2 is 2. Same thing with 3. Put it over 1. Bring down the minus sign. 3 times 1, that's our numerator. 1 times 2 is 2. Bring down the plus sign. Now I could put 4 here, but that's not going to help me because I need denominators of 2. So let's put a denominator of 2 there. And let's think, what would I multiply 4 by? Probably 2 to get this number here, right? 8. Isn't 8 divided by 2 4? So we've changed them all to have 2's in the denominator, which is awesome because that means we keep the denominator and deal with the numerator. So here we go. 7 minus 3 is 4, and 4 plus 8 is 12. And 12 divided by 2 is 6. So checked out. So that 1/2 can be in our answer as well. Don't be afraid of the fraction. Sometimes a fraction is what happens. Okay, let's flip our paper over. We got 2 more examples to do so that you can understand a little bit more what you need to do. I think some of you are catching on already though. Here we have 2 on the outside, and in parentheses we have 3x minus 2, and that whole thing's going to be equal to 20. Now, normally we would distribute, right? So let's do that. We give the 2 to the 3x, so 2 times 3 is 6, and the x comes with us. Bring the minus sign down. 2 times 2 is 4, equals 20. Nice and simple, right? We're going to get rid of the constant, which is a negative 4, so we're going to add 4 to both sides. 4's are going to go away. That just leaves a 6x on the left, and 20 plus 4 is 24. At this point, we're going to divide both sides by 6 because we want to isolate that variable, get that x alone. So x equals 24 divided by 6 is 4. Okay, we're going to check it. Okay, so 2 times 3 times 4 minus 2, and all of that equals 20. So let's start inside our parentheses. 3 times 4 is 12. Still in our parentheses, 12 minus 2 is 10. And 2 times 10 is 20. So it checks out. So x equals 4 is our answer. I'd like to show you a little something. You don't have to write this down, but I want to show you a little something to think about. If you have a problem like this, for this, I'm going to put this for our more advanced people, okay? If you're a little more advanced, okay, follow with me. Let me borrow the highlighter here. If this number on the outside of the parentheses can divide into the number on the other side of the parentheses, your first step could be to divide both sides by 2, because the 2's will cancel, leaving you the parentheses. Remember, this is 2 times the parentheses. It's the opposite of multiplying is dividing. This only works if that number is going to go into the number on the other side. If it doesn't, you're just going to end up with a fraction over there. Oops. 3x minus 2 equals 10. And this is kind of half of this one, right? So then you'd follow the steps, add 2. I think I'm going to run out of room. And then x is going to equal 4 again because I'm going to divide by 3. So we can see that it's going to end up being the exact same thing. So this is a thought for you. I would only do this if you actually see it and you kind of get the hang of it. Otherwise, this works every single time. So that might be some way to think about going. Okay, all right, pencils back up. Let's do one last example. So here I have 5x minus 5 times 4x minus 1 equals 20. I'm trying to put everything together now. A little bit of everything, some distributing, some collecting. Let's see if we go right down that hit list of what we're supposed to do. Okay, so let me draw a line here. Let's try to keep things, it's going to be kind of crazy, so we'll kind of keep things together. All right, so first thing I need to do is distribute. Now, I'm not distributing a 5, I'm distributing a negative 5. So make sure you do that, right? So I'm going to keep this 5x here because that's going to stay. Negative 5 times 4x is negative 20x. Negative 5 times negative 1, negative times negative is a positive, 5 times 1 is 5. Okay? And then that's going to equal 20. All right. So then remember our next step was collect like terms if it's necessary. Well, it's going to be necessary here because I got 5x minus 20x. So that's going to give me negative 15x plus 5 equals 20. Now I'm going to work on the constant. Now we're at a two-step equation. We know how to do this. So adding 5, we're going to subtract 5. Negative 15x equals 20 minus 5 is 15. Again, we want to get the x alone, so let's divide both sides by negative 15. And we find that x equals a positive divided by a negative is a negative. Any number divided by itself is 1. So we're thinking it's negative 1. So let's check. And let's plug it in. 5 times negative 1 minus 5 times 4 times negative 1 minus 1, that's all in parentheses, right? Equals 20. All right, let's work from the parentheses out. And we can fix this. 5 times negative 1 is negative 5. So let's leave all of this out there, and let's work in the parentheses. 4 times negative 1 is negative 4. Still in the parentheses. Negative 4 and a negative 1 gives me negative 5. A lot of negative 5s over there, aren't there? So remember, we got to multiply before we add and subtract. So we're looking at a negative 5 times a negative 5, right? So negative 5 times a negative 5 is positive 25. And a negative 5 plus a positive 25 is a positive 20. This is one of those things that the sign is going to kill you if you don't pay attention. Okay? So you really want to go slow. When there's a lot of positive and negatives going on, you want to go slow and be sure that you've got the right thing. Okay? All right. That's the end of our lecture.